Hello everyone. Today we are going to discuss the part C, that is data pre-processing for feedback analysis of first internal test. Ninth question is student faculty feedback data may suffer from issues like accuracy, completeness and consistency. Discuss each issue in this context. Propose two other dimensions of data quality relevant to learning analytics. Faculty feedback data often exhibits several quality issues that can affect the reliability of analytics and institutional decision making. Accuracy problems arise when students provide careless, biased, or unintentionally extreme ratings. Example, giving all first or all fives regardless of actual experience, or when data entry errors occur during manual transcription. Completeness issues are common because many students skip questions or provide partial survey responses, resulting in missing values for key attributes like faculty responsiveness or infrastructure support. Consistency problems occur when different parts of the feedback contradict each other. For example, a student rates overall satisfaction as high but gives very low scores for all contributing components, or two versions of same survey yield different rating scales 5.1 versus 5.10. These inconsistencies create difficulties for aggression, comparison, and modeling. Beyond this, timelessness is another crucial dimension. Feedback collected too late may no longer reflect accurate perceptions and cannot be used for rapid instructional improvement. A second important dimension is validity, which concerns whether the survey questions actually measure what they claim, whether infrastructure satisfaction is captured by appropriate items. Ensuring high data quality across these dimensions is essential for trustworthy learning, analytics, and evidence based faculty development. Moving on to 10th question, handling missing student feedback values. Discuss approaches such as ignoring tuples, filling manually, using global constants, mean, median, mode imputation, class specific imputation, or using predictive methods. Solution is missing values are common in student feedback datasets, and several strategies exist to handle them depending on the analytic goal and the extent of missingness. The simplest approach is ignoring tuples, where records containing missing fields are discarded. This is efficient but only acceptable when missingness is minimal and random. Manual correction, reviewing, and filling values by hand is feasible for very small datasets but unrealistic at scale. A basic automated operation is global constant imputation, replacing all missing values with a placeholder, example unknown or zero. Though this can distort distributions, more informative are mean, median, mode computations, which substitute missing numerical values with the overall average or central tendency, and categorical feeds the most frequent category. When feedback differs across groups, class specific imputation applies separate means or modes within each subgroup, preserving more structure in the data. The most sophisticated strategies use predictive methods such as regression, k nearest neighbors, decision trees, or more advanced machine learning models, which infer missing values based on relationship with other attributes. These predictive approaches often lead more accurate imputations but require more computation and careful validation to avoid introduction bias. Moving on to 11th question, we need to consider feedback ratings, same as question number 2 that were discussed in part A. The first is smooth ratings using bean means bean depth equals to 3. Step 1 is sort data that is already sorted. Step 2 is create beans of size 3. This is the bean we created. So the smoothest data set is given here. Second part is suggest ways to detect outliers. First is statistical methods using z-score or standard deviation, using intra-quartile range IQR. Second point, box plot visualization. The upper whisker will reveal the higher outliner 70. Third is testing density based methods using clustering or distance measure to flag rare values. Third part is discuss other methods for data smoothing. Bin median smoothing. This replaces each value in bin with its median instead of mean. Bin boundary smoothing. It replaces each value with nearest bin boundary. Third, moving average. Smooth a little series style dataset by averaging over a sliding window. Fourth is lose something, weighted local regression for complex trend estimation. Fifth, exponential smoothing, applying decaying weights to older data points. Moving on to 12th question. In data integration for MCA MTech analysis, discuss schema integration handling redundant data and resolving conflicts in values. First is schema integration, that is, different surveys may have varying attribute names or scales. First is use attribute matching. Second, employ metadata repositories or ontologies to unify schema. Second point is handling redundant data. Is multiple entries may exist for the same student or faculty. We can identify duplicates using unique IDs or fusing matching or merge or average duplicate feedback entries. Third is resolving conflicts. Data conflicts occur when sources disagree. We can use source reliability weighting or use median instead of mean to reduce bias or apply data provenience tracking for adaptability. Moving on to next question, that is 13th question. We need to discuss normalization methods. First is minimum maximum normalization method. The formula is given here. Second is z-score normalization. The formula is given here. C is normalization using mean absolute deviation. The formula is here. Last is decimal scaling. This is the formula for decimal scaling. Moving on to next question, that is 14. Normalize the following faculty workload values per semester. First part, we need to calculate minimum maximum normalization that ranges to 0 to 1. These are the values calculated. B part is z-score normalization where nu equals 1 and sigma equals 1. According to the formula, the value comes is 282.84. Moving on to next question, that is 15. Using the feedback ratings data with highest value 35, compute normalization for 0 to 1. First part is minimum maximum normalization ranges to 0 to 1. This is the formula. When we put values, the value comes to x equals to 0.386. B part is z-score normalization where sigma equals to 12.94. The value of z-score equals to 0.223. C part is decimal scaling. According to the values, when we put it into formula, the value of x comes to 0.35. Last part is discuss which method is appropriate and why. Minimum maximum normalization is most appropriate for feedback ratings in most practical settings. For these reasons, feedback ratings are naturally bounded. Minimum maximum maps that bounded range to 0101 in a straightforward, interpretable way. So a near value 0 means very low, near 1 means very high. Third is interpretability for stakeholders, managers, educators, reading normalized scores on a 0-1 scale, understand them intuitively. Fourth is preserves relative distances within the original bounded scale, useful when you want to normalize values to reflect